Good morning, good afternoon, good evening, depending on when you're accessing this content. On this video, I'm going to be taking you through Lab 4.3 of HCAI Datacom. This lab is about configuring network address translation. So as we already understand, network address translation translates the IP address of an IP packet header to another IP address, either from a private IP address to public or otherwise. Now, NAT provides the following advantages other than just translating. The IP addresses on the IP header, it also provides the following advantages. The first one is that it protects private networks against external attacks. So I'm going to be demonstrating that. Number two, it enables and controls the communication between private and public networks. So we're also going to see how we can be able to enable people on the internet to be able to access our private clients using the NAT server configuration. So the objectives of this lab is you learn how to configure dynamic NAT, easy IP, and lastly you also learn how to configure NAT server. So this is the network topology. What we want is the network between R1 and R2 is an intranet, so private network, and uses private IPv4 addresses. While on the other hand, R1 functions as the client and R2 functions as the gateway. So R2 is the gateway of R1 and the egress router connected to the public network, while R3 simulates the public network. So here I have my topology. So this is the private network, this is the public network. R1 is the client. You can think of it, for example, as a PC or even a server. Then this is our gateway that is connecting us to the internet, and we have a server on the Ethernet. So R3 here is representing that. So between R1 and the gateway, we use private address 192.168.1.0/24, while between R2 and R3, we use the public IP address 1.2.3.0. Okay, so one thing that I noticed is that earlier I had used this router. But I realized that NAT was not working on that router, so I changed it to the AR2220 version. So I chose this one. So please make sure that you also use the AR2220 for it to work. Okay, so let's begin. So the configuration roadmap, we're going to configure dynamic NAT, then easy IP, then NAT server. So step number one is on configuring the basic configurations. One thing I haven't mentioned is that I haven't used these exact interfaces, G003 and G004 and 3 here. Instead, I've used G001 between R1 and R2 and G002 between R2 and R3. So I hope you're not going to be confused because of those interface numbers. So let's begin with step number one. In step number one, we are supposed to configure the IP address and routes. Really, we are supposed to configure the interface IP address, but also the static route on R1 to the gateway 254. We're also supposed to configure IP addresses on R2 interfaces and a static route to the server on the internet. 1.2.3.254. After that, we are supposed to configure telnet. We want to configure telnet on R1 and R2. R1 and R3, so that we can be able now to communicate or telnet from R1 to R3 and vice versa. So this exercise needs us to do that. So let's begin. Okay. So I haven't done any initial configuration, so I'm just going to begin from the very top. R1, R2, Then we name this one and do terminal monitor, system view, R3. Good. Okay, so let's begin with R1. So with R1, we go to the interface G001. We configure, so reint G001. Configure an IP address 192.168.1.1/24, like that. The other thing we need to do here is to configure the gateway. So we configure a static route. So IP route static 0.0.0 mask 0. Then we want you to send it to 168.1.254. If you get anything you don't understand, send it there. Okay, let's now go to R2. So R2 on interface G001, we configure the IP address 192.168.1.254/24. Okay. On R2, we also go to int G002. We configure the public IP address 1.2.3.1/24. Then we configure the static route to R3. So IP address 0.0.0.0. So if you have a packet whose destination you do not know, just send it to this guy, 254. Okay. Sorry. It's supposed to be IP route static 0.0.0 1.2.3.254. Okay. Oh. Route static. Enter. Okay. So now we can go ahead and configure R3. So R3 we go to interface gigabit Ethernet. As you can see at the background there, 002. Hi. 002 IP address 1.2.3.254. Okay. So we can always confirm with display IP int brief. Okay. So we have that. We can ping -C. We just want 1.3. We ping R2. Okay, so that is successful. We can also ping 192.168.1.254. Okay, so we are able to also ping our gateway from R1. Okay, so the next thing we want to do is to configure users and configure telnet on R1 and R2. So we can go to AAA, then local user test, password cipher, Huawei at 123. Then we can enable test service. We can enable the service type to be telnet. Telnet, enter, then local user privilege or test privilege label. Can give him 3, like that. So we're also gonna create the same user on R3. So we get to AAA local user test password cipher Huawei at 123. They have to be the same. Then local user test service type telnet. Then local user test privilege label 3, like that. Okay, so after we've done that, we can go ahead and create the VTY interfaces. So quit. So user user interface VTY 024. Then here we just do authentication mode AAA, just like that. Similarly here on R3 we do user interface VTY 024 authentication mode. We want it to be the authentication mode. We want it to be AAA. The other authentication modes, of course, we have password. So we want AAA. Enter. Okay. So we've configured telnets on R1 and R3. Okay. So let's see. Are we able to ping R3 from R1? Ping -C. We just want to send two requests. 1.2.3.254. So we cannot be able to ping R3 from R1 simply because we have not configured NATing on R2. In order to enable R1 to be able to reach R3, we have to configure NATing, because yes, this packet will be sent to R2. R2 will send it to R3, but R3 does not know. It does not know this source address. Does not know the source address of R1. So really, the packet will pass. The packet will be forwarded via this. If we do data capture here, then we go back here and do the ping again. Ping. So as you can see, the packet will be captured with a source address of 192.168.1.1. So R3 will receive. It will receive this particular request, but R3 does not have, and because it's on the internet, it cannot have a private IP addresses on its routing table. So that's why we need to configure NATing on R2. So that is the next step that we are going to do. Okay. So on step 2, the enterprise obtains the public IP address ranging from 1.1.3.10 all the way to .20 and needs the dynamic NAT function. So we want to configure the dynamic NAT. To configure NAT is easy. You only have to do 3 things. The first thing is you create the address pool using the address pool command, address group command. Then you go ahead and configure an SCL that is going to capture those packets, and after that you now configure dynamic NAT on the outbound interface on R2. Okay, so let's do that. So we have to do this on R2. So on R2 we use the command NAT, then address group. If you do question mark, you see you can give your address group a number between that. If you do a question mark after giving it an ID, we've given it an ID of 1, you see that you need to specify the start address. So the start address is 1.2.3.10, like that. Space, question mark, you need to do the end address. So 1.2.3.20. You remember the scenario, they said that we have this range. So that is the address group. So that's the first thing you do. After that, you just create a basic SCL. So SCL 2000. Then you create a rule. For example, rule 5, permit source any, so that it can match all the packets that are passing through. Okay, so after you do that, you can go ahead and configure the outbound interface, which is GE002. So how do you do that? You go into G002, then you use the command NAT outbound, not outbound. Then if I do question mark, you see we are supposed to specify the ACL. The purpose of the NAT outbound command is to map or join the ACL with the address group. So we created ACL 2000. So after that, you now need to specify the address group. The address group, if I do question mark, you see we need to give the index of the address group. We created address group 1. So let me just clear this. Okay, so NAT outbound 2000 address group 1. So on G002 on the outbound interface, so that is where the translation, that is where the NATing is going to be performed. Okay, so we do enter. Okay, so we can confirm, for example, using the display command, for example, display NAT address group 1, if you want to see. So that's how you confirm that indeed the index is 1, the range is from .10 to .20. You can also display ACL 2000, for example, just to view it. ACL 2000. And if you want to verify if indeed you've configured NAT on the outbound interface, you can use the display this, for example, command. You go into the interface and then display this. So indeed we've mapped the ACL 2000 to address group 1. So any packets that match this particular ACL, they're going to be translated to a public address in this address group range. Okay, so now the next thing after configuring that will be to test connectivity. To test connectivity, we now ping R3 from R1. Okay, so before we do that, I also want to do a data capture here. I know we have done a data capture here, so we also do a data capture here. Let me also clear this one. Okay, where is it? Okay, restart. Sorry. Continue without saving. Okay, so this is the capture on the outbound interface, but I also want us to do a data capture on the inbound interface here before we do the ping from R1. Okay. Okay, so let's now do the ping and see whether it's gonna go through. Before it was failing, as we've seen there. So if we do ping again, so ping, we just want to do 2, so negative 1.2.3.254. Okay, so you can see that the ping has been successful. Let's see what happens on the inbound interface. So focus on the request. So you can see that for the request, the source IP address on the IP header is 192.168.1.1. So that is the very fast request. Let's have a look at what happens on the outbound interface. Did it capture? No, it didn't capture. Okay, let me just close it. Then we repeat this again. So let me do a data capture here. Okay, then I repeat the ping. Okay, so you can see that on the outgoing interface, the private IP address 192.168.1.1 has been translated to the source of 1.1. You can see 1.1.2.3.16. 1.2.3.16. So that is our new source IP address. So it really proves that indeed the translation has happened. You can also use the command on R2. You can use the command display NAT session all. So this command is used to display all the mapping between private and public IP addresses. Takes a little time. Okay. Maybe that has already been erased. Let me just do the ping again, then do display. Okay, good. So we can see here that these packets, which is an ICMP packet, it came in with the source of that, and it was translated to this new source address 1.1.2.3.16. So really, that command display NAT session all is used to exactly do that, to confirm the mapping between internal and the public IP addresses. Okay, so the next thing we want to do is to configure easy IP. So what we've just done is dynamic NAT. Now, the main difference between easy IP and dynamic NAT is that with easy IP, the outbound interface can only acquire a single public IP address. So we don't have a pool of IP addresses. We just have one IP address, and most of the time that IP address is assigned via PPOE dial-up. So we're also going to learn about PPOE, so you're going to understand how this really works. But most of the time, the ISP will assign your router a public IP address, that one that you have at your home, so that you can be able to use it temporarily. So that is what we call PPOE dial-up. So if it has a single IP address, then we don't use dynamic NAT, because dynamic is when you have a pool. We use easy IP. So to configure easy IP is quite easy. The first thing we have to do is to undo this command on the outbound interface. So we need to undo that command. Then we need to use the command NAT outbound 2000. NAT outbound 2000. So let's do exactly that. So here on R2, we go to the outbound interface G002, as you can see on the background there. Then display this. Then we use undo, NAT outbound 2000 address group 1. So this time we don't have an address group, so the command is just NAT outbound 2000, like that. NAT outbound 2000. So when you do that, then really you have configured easy IP. So all your internal private addresses are going to be mapped to this public IP address for the interface of the outbound interface. Okay. So if I do the ping again, and come here and use the command display NAT session all, we can also confirm from here. We can also confirm from here that the requests now are coming with the source IP address of 1.2.3.1. So the source now is no longer 16. We just have a single public IP. So just one. Okay. So you can see when we display the NAT session, this one, the new one, so just a single public IP address. The only thing that will be differing is the port numbers. Okay. So that is how to configure That is how we configure. That is how we configure easy IP. So that was step number 3. So let's go on. Let's go on and telnet R3 from R1 to simulate TCP traffic. Okay. Okay, so we telnet R3 from R1 and see whether it's gonna go through. Okay, here. So telnet 1.2.3.254. So as you can see, indeed, it asks us to give a username and a password. I think that was test, and this was Huawei at 123. So just type the password to the end, even though it won't show. So you can see that we are now on R3. We've telnetted into R3. We can do quit in order to end the telnet and go back to R1. So indeed we are able to telnet to R3. But now, is it possible for R3 to reach R1? Is it possible for R3 to reach R1? Remember, we said the other benefit of having NATing is that we protect our internal devices from the external public network. So we cannot be able to reach R1, which is on that IP address from R3. We can't be able to reach it. Now, even if I'm not sure whether this session is still on. Let me just check. Or let me just ping. Okay, so I've just pinged R3. Let's see. I want to see the mapping. Okay, so of course, because we have easy IP, it will just be mapped to that. So let's see. Really, we cannot be able to ping this internal. We're going to be able to ping this internal from the public network. We cannot be able to do that. We cannot be able to reach it. So that is what I want you to understand. Even when we had configured dynamic NAT, if we displayed the session, and for example, it had been translated to .16, we could not be able to ping .16. So I hope you understand that. Okay, so if we want our internal servers to be accessible from the public, then we need to configure the NAT server. We need to configure the NAT server. So you can see, for example, here. No, there's even no need of doing that. Okay, so let's go to step number 4. So in step number 4, they confused a little bit. This is supposed to be R1. So R1 needs to provide network services, telnet in this example, for users on the public network. So because R1 does not have a public IP address, you need to configure NAT server on the outbound interface of R2. So that is what we want to do. Now, to configure NAT server, you go into the outbound interface of R2, then you use this command. So let me just copy it. So we go to R2. We go to R2, and then we go to int g0/0/2. Then I can paste that command. It's quite long. So the command is NAT server. Then the protocol we want to map with is TCP. So the TCP port numbers on the global. We want to use the IP address of the current interface. So the IP address of this one. On the and TCP and the port number 2323. Then on the inside, we want to use we want to use this private IP address, which is the IP address of R1, and the TCP port number of Telnet, which is 23. So if we configure this now, then anyone coming from the global with 1.2.3.1 and TCP port number of 2323, they are going to be translated to that. And by configuring that, then this guy can be able to access, they can be able to access R1. So right now, if we do telnet 1.2.3.1 on port 2323, you see, if we try to do that, we cannot be able. We cannot be able to telnet via that port number. Okay, so let's use this command, enter. Okay, so let's try this again. Are we able now to telnet to R1? You see, we are now able to telnet because of configuring NAT server. So we can enter the username here. The username test, password Huawei at 123, and boom, we are on R1. So we are now able to access R1 from the public network because of configuring NAT server. So that is the purpose of configuring NAT server. So ladies and gentlemen, that is the end of this particular session. Maybe just to use the command display NAT session all. Let's see. We just want to see the mapping of the port numbers and IP address. So in case you are using dynamic NAT for example, you've excluded the IP address of the server, here instead of using current interface, for example, you can use the specific IP address, for example 1.2.3.16. Okay, so we can see that we have which one? Source address. This one. Source address is 1.2.3.254. Destination, it's going here. So that one, if it comes like that and it's on TCP, it's going to be sent to this address, to that address. So that is how NAT server works. Ladies and gentlemen, thank you very much for your time. I hope you've enjoyed, and above all, you've been able to learn. Interact with me on the comment section. If you have any question, I'll always create time to reply. Asanteni sana.